Hello and welcome to our presentation. This is Team 5, the Intraoperative EMG Waveform and Identification Team, sponsored by Stryker Instruments. My name is Rachel Ping. I am a Biomedical Engineering Senior, and this is our team. We have Joshua Ayres, Tony Ha, and James Roland. Our team was tasked with intraoperative EMG waveform identification, which revolves around the principles of intraoperative nerve monitoring. The basis of IOM, for short, is that it is a valuable observation technique that gets used during complicated surgeries to determine the state of the nerve. The market for IOM is quite expansive. It's in excess of $1.5 billion, and electromyography specifically, which is a subset of IOM, accounts for a fifth of this market. The focus of IOM is to minimize damage to nerve systems and to ensure the success of the procedure. The characterization of the IOM signal helps us determine if there's damage or irritation to the nerve. Our team was tasked specifically with identifying true EMG responses and differentiating them from surrounding noise, which helps limit false responses. Our team used needle electromyography specifically to accomplish these tasks. Our secondary prototype that we developed in the spring semester involves a function generator that simulates the EMG signal within the saline environment. We use the needle differential probes in combination with an analog digital converter, a myAware sensor, an Arduino board, and finally a computer for processing of the signal. We also developed a bandpass filter as part of our hardware solution for the prototype. However, we weren't able to introduce that due to quarantine measures. These series of photos help illustrate our final configuration of our prototype, but the video on the following slide will help detail how these connections are configured. This is an example of one of the results from our software solution. We applied a bandpass filter and performed wavelet transformation on the received EMG signal to remove the noise and to increase the sensitivity to the EMG signal. This is an example of the cleaned EMG signal that we're able to achieve using our software solution. Should another team choose to accomplish our project, we propose the following theoretical steps in addition to our work. Introduce the physical bandpass filter into the prototype configuration before it is connected to the Arduino. Increase the verification of the signal reception through the capture of several different types of EMG waveform, slowly introducing individual sources of noise to improve the software solution. Introduce physical surgical equipment into the saline environment to better mimic the operating theater, and complete the audio warning system after waveform analysis. We would also like to take the time to acknowledge and graciously thank our sponsors, supervisors, faculty, and staff who without their guidance this project would not be possible.